Hello and welcome. This presentation is about the data provided by the BigO project to the Eurostat Big Data Hackathon for 2019. First, the BigO project will be presented, as well as how the data for the hackathon were collected. Then, the extracted behavioral indicators will be presented in detail. A description of the participants' self-reports will follow. Finally, the raw data which have been recorded will be presented as well. So, what is the BigO project? BigO aims to collect and analyze big data regarding obesity, both on the individual behavior level and the environmental level, in order to extract associations and correlations between the conditions of the urban, social and economic environment and the obesogenic behavior of the population. These correlations are extremely useful to the public health authorities to optimize their policies. Many factors have been identified and categorized so far. BigO collects data for factors of the two outer circles. BigO is developing many tools for that purpose: behavioral and environmental indicator extraction algorithms, visualization engines, and tools for implementing association studies. The BigO system was used by volunteers and participants to record data for the Eurostat's Big Data Hackathon. The raw data were recorded using an Android application for 19 days. The recorded data were then processed by algorithms to extract behavioral indicators, and both the raw data as well as the extracted indicators were made available for the hackathon. The recorded raw data consist of sensor signals such as accelerometer and battery level. Care has been taken to reduce the battery burden by not recording when the mobile phone is left motionless. More on this on the raw data section. Location data are also recorded as part of the raw data. They contain mainly latitude and longitude coordinates as well as additional information. Finally, the behavioral indicators are provided in tables per user. 3 tables are computed regarding physical activity, visited locations, and transportation mode. In this section, the extracted behavioral indicators will be presented in detail. Physical activity is quantified in time intervals of 10 minutes. For each 10-minute interval, the following indicators are extracted: activity counts, as would have been computed by an actigraphy device, number of steps walked, and finally the type of activities that were performed by the participant in that time interval. Absolute time and location are also provided for each time interval. Note that the location is provided in the geohash encoding in this case. The geohash encoding is a way of preserving privacy for location data, since the exact coordinates are not revealed. However, it is interesting to explore if such levels of location information can be useful for extracting useful patterns for participants' behavior and time use. One physical activity table is provided for each participant in the form of a CSV file. The file's columns are presented here in detail. Each 10-minute interval is represented as a single row. Note that the timestamps column corresponds to the interval's start time. Visited locations are extracted using an algorithm based on density clustering on the basis of the raw location data. Each visited location is a place where the participant stayed or visited. For each visited location, the location is provided, encoded again as a geohash, and a general characterization for the place, such as park, restaurant, etc., obtained from Foursquare. Finally, arrival and departure times are also provided. One visited locations table is provided for each participant, again in a CSV file. Each row corresponds to a single visited location, and the file's columns are presented here in detail. Finally, transportation mode is provided for trips between visited locations when possible. It is extracted using machine learning on the accelerometer data recorded between successive visited locations. The result is provided as the histogram of time spent traveling on a set of transportation modes such as walking, car or bus. Time and location of the departure and arrival visited locations are provided too. Similarly, transportation mode is provided as a table, one for each participant. Each row corresponds to a trip and the file's columns are presented in detail here. This section presents the participant self-reports. Daily answers are provided as individual JSON documents organized in one folder per user. The structure of the JSON document is quite simple. It contains the date and time the answer was provided and the answer as an integer. Meal reports are provided as a pair of files, a JSON file and a photograph file. The structure of the JSON document is shown. It includes date and time information, location information, information regarding the phone's posture during the photograph, and a description of the meal's attributes. The next section describes the structure of the raw data and the metadata that are provided with them. Raw data are recorded in sessions. A session is a logical organization structure for the raw data. Sessions are shown as gray boxes in the plot. Each session can last up to 4 hours. If a session reaches 4 hours, it immediately ends and a new one starts directly after it. In this example, session 22 reached 4 hours and ended and was immediately followed by session 23. A session can also end if the phone enters doze mode. Doze mode is a feature of the Android operating system that occurs during times when the phone is left completely motionless. When the phone exits doze mode, a new session starts. In this example, the phone was in doze mode until 9 a.m. and thus no recording took place. Sessions 20 and 21 occurred because even during doze time, the operating system still wakes up for a few seconds to briefly perform some checks. Raw data are organized in a single folder for each participant. There are two CSV files containing metadata, namely the session CSV and the data file CSV. Each session is stored in its own subfolder. Finally, the location CSV file contains all the recorded raw location data. This table presents the columns of the session CSV. Each row corresponds to a single session. The columns device ID and session ID can be used to obtain the name of the subfolder of the corresponding session. Start and stop timestamps are provided as well. Finally, the start cause and stop cause columns can be used to identify periods of doze mode. Note that during doze time, no raw data are recorded and thus no extracted indicators are provided as well. However, it is safe to assume that during these doze periods, physical activity is close to zero, for example, 0 steps were walked. However, this information can be useful in the processing of the data and it is advised to take it into account during the analysis. This table presents the columns for the data file CSV. Each row corresponds to a single binary data file. Normally, there is no need to access this file since raw data parsers are provided. As mentioned, a Python module is provided for parsing raw data. This code shows an example of how to read the sensor data. You need to provide the path of the session and the type of the sensor you want to parse to the read session data method of the file parsers module. The timestamps and the sensor channels are provided in a single matrix. For the accelerometer sensor, 3 channels of data are returned corresponding to the x, y, and z axes. Units are in meters per second squared. Finally, raw location data are provided in a single CSV file. The columns are described in this and the next slide. The coordinates latitude and longitude are in degrees. To sum up, in this presentation we saw the recording approach followed by the BigO project, a detailed description of the extracted behavioral indicators, the self-reports that were provided by the participants, and the structure of the raw data on the basis of which the behavioral indicators were extracted. For any questions, you can contact the following people. For technical questions regarding the data, please contact Vasilios Papapanagiotou. Thank you very much for your attention and good luck.